ladies and gentlemen, boys and girls, friends and neighbors. Here is another video over analyzing quadratic functions. Just for another example, we will go through one problem. So I've got this function, this quadratic function, f of x equals negative x squared minus 4x plus 1. First thing we're going to say, hey, the domain is all reals. This will be very important next year. It's not so important this year, but it will be very important. So we need to, whenever you analyze any function, the first thing you do is you talk about the domain. The next thing we're going to do is we see that all of our notes have said is we're going to find the A, we're going to find the B, and we're going to find the C. So A is going to be negative 1. It's the coefficient of the x squared term. B is going to be negative 4. It's the coefficient of the x term, and C is going to be 1. So I've got A is negative 1, B is negative 4, and C is 1. Next thing I'm going to do is I'm going to say, hey, this A, which is equal to negative 1, this is less than 0. So the graph opens down. It opens down, therefore the vertex, and if I do a little sketch, and this is always just as an aid, if I do a little sketch of something that opens down, I can say right off the bat the vertex is a max point. So I know since A is negative 1, which is less than 0, the graph opens down, the vertex is a maximum point. So it only makes sense. The next thing I'm going to do is find the vertex. The first step in finding the vertex is evaluating negative b over 2a. In this case, negative b is going to be negative 4. So it's going to be negative 4 over 2 times negative 1. Negative 4 is 4 divided by negative 2, and that's negative 2. So the x-coordinate of the vertex is going to be negative 2. What I need to do is I need to evaluate that function at negative 2. To find the y-coordinate of the vertex, let's do this mathematics. So this is going to be f of negative 2 is going to be, it's going to be negative, and this gets tricky because we've got so many negative signs going on here. This is going to be tricky. You just have to be very careful. That's why on any example I've shown you, I always use parentheses. Okay, so it's going to be negative 2 squared minus 4 times negative 2 plus 1. Negative 2 squared is going to be 4, so this is going to be negative 4 plus 8 plus 1. So 8 plus 1 is 9 minus 4 is 5. So f of 2 is 5, so therefore the vertex is going to be negative 2 comma 5. So that's what this vertex over here is, negative 2 comma 5. And I can wait till I can graph it, or I can make all these statements right now if I want. Well, I know it opens down. I know the vertex is negative 2, 5. Right away, then, by my notes, I know that the range, let's call it the range, Lee. The range is going to be y less than 5, because it's going to be all of these values here. All of these y values less than this 5 value there. The other thing I know is that this particular graph increases. It increases, then the graph decreases. So right away I can say, hey, you know what? This thing increases when x is less than negative 2. That's when this guy increases, and it decreases when x is greater than negative 2. And what else do you know about the vertex? That the line of symmetry is x equals -2. So the vertex can tell you so much information. I have the vertex and the fact that the graph opens down, along with the vertex and the graph opening down. I can find the range, bam. I can find where it increases, bam. I can find where it decreases, bam. And I can find the line of symmetry. So what we're going to do now, if you look at your notes, and if you're reading your notes along with this video, is the next thing we're going to do is we're going to find the discriminant. And the discriminant is going to tell us a lot about the x-intercepts. So I'm going to find the discriminant, which is b squared minus 4ac. Please use your notes on the quiz, use your notes on the assignments. So the discriminant is going to, let's rewrite the function here. Functions was -x squared. Let's copy it down here. -4x plus 1. So the discriminant is going to be -4 squared minus 4 times a, which is -1, times c, which is 1. Okay, so a is -1. We already decided that. A is -1, B is -4, and C is equal to 1. Sorry about the penmanship there. And so what is this? This is going to be 16. Negative times negative is positive. 4 times 1 is 4. So the discriminant is going to be 20. And since the discriminant is positive, which is equal to 20, and it's positive, there are 2 x-intercepts. And now what am I going to do? Now I'm going to use the quadratic formula that you will never have to memorize to find the y-intercepts. The y-intercepts are going to happen when the function, which is this guy right here, that's going to happen when this is equal to 0. And how do I solve this? Well, I solve this with the quadratic formula. And here's the quadratic formula. X is going to be -b plus or minus the square root of the discriminant, which is b squared minus 4ac over 2a. So it's going to be -b, so therefore x is going to equal -4 plus or minus the square root of 20. We already found the discriminant, over 2 times -1. So that's going to be 4 plus the square root of 20 over -2. I don't like that equal sign there. And the other x-intercept is going to be 4 minus the square root of 20 over -2. And now we have not seen one. I don't think we've encountered one where the discriminant was not a perfect square. So all of you have a calculator in your phone or on your computer. And what I want you to do is pause the video and find those with your calculator. And you have to be very careful. I'm going to write those down, and you make sure that you can do these with your calculator that's on your phone or another type of calculator. I don't care. All you need is a scientific calculator. Okay, so I'm going to take this in my calculator. I've already have it figured out here. 4 plus the square root of 20 over -2. That is equal to, well, it's approximately -4.236. So that's going to be one x-intercept, -4.236, 0. And this guy right here, for minus square root of 20 over negative 2, that is equal to 3 decimal places. Make sure you use 3 decimal places. So we're going to keep the AP mathematics requirements of at least 3 decimal places. So the other x-intercept is 0.236, comma 0. Okay. Keep in mind at any time you can pause the video. Next thing I'm going to do is find the y-intercept. The y-intercept is always going to be easy. The y-intercept is always going to be 0, comma c. In this case, c was 1. It's just 0, comma 1. Okay, so my c was 1 right there. Sorry. So I'm going to write all this information down on the next slide. I have my vertex. My vertex was equal to negative 2, comma 5. I'm going to write all this information down on the next slide. I'm going to pause the video while I do that. Okay, so I copied the information down. The vertex, and I'm looking at this, I'm analyzing this function. The vertex is negative 2, 5. Bam, right here it is, negative 2, 5. The graph does open down, opens down. Why does it open down? Because a, which is equal to negative 1, is less than 0. I have my x-intercepts here. That's a little bit over negative 4, a little bit to the left of negative 4, a little bit to the right of 0. They're really hard to see, but you can see them right there. Just make sure you graph them appropriately. You got your y-intercept right there, 0, comma 1. You have your line of symmetry. I wanted that yellow. You have your line of symmetry here, which is x equals negative 2. You know the graph increases when x is less than negative 2. The graph decreases when x is greater than 2. So I've got increasing. I've got decreasing. I don't like that increasing in yellow. I have my line of symmetry. I'm increasing at the concave down. I think that's it, folks. It's just another example. And I will see you.